Hi everyone and welcome to another math revision with Jov. Apologies for the incredible lack of videos. It's been a very hectic time during my course, so I've not been able to make any videos, which is unfortunate, but luckily for you I am back now. And today's question reads: the line L1 has the equation 2x plus 3y plus 5 equals 0, and the line L2 passes through 1, 7 and 5, 1. And it wants us to say whether these lines are perpendicular, parallel, or perhaps neither. So we're trying to show that this line L2 is either perpendicular or parallel to, or possibly neither, to this line L1. Now what that means is we want to find the equation of this line L2 and compare it to line L1 and see if they have any similar properties. So to do that, first we're going to try and find the equation of the line L2. So we know that, the equation of a straight line, we'll call it y equals mx plus c for now, where m is the gradient of the line and c is the part of the y axis that it intersects. We can insert some of these values into here and see what comes out. So we'll put 1, 7 in first. So when x equals 1, y equals 7. So 7 equals m times 1 plus c. So I'll just write that as 7 equals m plus c. And for the other one, 1 equals m times 5 plus c, which is just the same as saying 1 equals 5m plus c. We can actually go ahead and solve this as simultaneous equations. So we can solve for c in both cases. So you get c equals 7 minus m and c equals 1 minus 5m. Then we get this equation, 7 minus m is equal to 1 minus 5m. And that's because we've got both of these as equal to c, so they must be equal to each other. And we can solve this, so we can go ahead and add 5m to both sides. So we get 7 plus 4m, because 5m minus m is 4m. That's equal to 1, so 4m is equal to 1 minus 7, which is minus 6. So m is equal to minus 3 over 2. So because I've done minus 6 over 4, it's just minus 3 over 2. Great. Now we can go ahead and solve for c. Well, we've got c over here. So c equals, I'll use 7 minus m. So 7 minus m, which is minus 3 over 2. So c equals 14 over 2 plus 3 over 2, which is 17 over 2. Great. So now we get that y is equal to, well, this is for L2, remember? So y is equal to minus 3 over 2x plus 17 over 2. We can actually go and rearrange that to make it look like this equation over here. So we can multiply both sides by 2, I guess. So 2y equals minus 3x plus 17. We can put everything on one side, so we get 3x minus 2y. Wait, no, that's a plus, because I've put 3x on here. So 3x plus 2y minus 17 equals 0. Now, if you notice, we've got 3x plus 2y here, but over here we've got 2x plus 3y. So that's not exactly the same order. And when you get that, what that means is that they are not, well, we know for a fact that they're not parallel, because if they were parallel, then we'd have 2x plus 3y both times. So they can't be parallel. Can we see if they are perpendicular? Yes, we can. We can go back to this form over here. So we've got y equals minus 3 over 2x plus this constant, I'll just call it k because it doesn't really matter what the constant is. And then for this one over here, we've got y, so I'll say 3y is equal to minus 2x plus 5. And then we can divide by 3, so y equals minus 2 over 3x plus 5 over 3, but it doesn't really matter what the constant is again, so you can just call that, I don't know, big C for now, because it doesn't matter at all. And then all we want to do is look at the gradient of both lines. And the gradient of this first line is minus 3 over 2, and the gradient of this other line is minus 2 over 3, which means you're going to have two lines that look kind of like, well, one of them will look a little bit like this, and one of them will look a little bit like this, which are obviously not perpendicular. So we are done. They are neither parallel or perpendicular.